Alright, bit of a add-on to the previous video on lesson 1. That forces moving a speed are time dependent. Essentially, you can't undo that fact. So relevant to that was a description of an experiment, okay, where you're going to separate things like a magnet that's controlled by a force between the magnets, and the force is time dependent because it's a time motion force. It's moving at a certain rate. It happens at a rate. So any force that's happening at a rate, okay, is going to be qualified as time dependent. Now the trick is the experiment was first done with a pendulum that was on a string, and I didn't notice that he changed the experiment to a pendulum on a stick. So time dependence isn't really important once you've changed the pendulum so dramatically. So I'll point out the bigger problem with his video. So this little bit really won't be time dependent argument. It will be something more obvious. And something I shouldn't really have to explain. He should have figured this one out on his own. So you can have a pendulum, and you make this irrelevant by making it so light that it's 1,000 times lighter than the object you're moving, and then your mass can just be understood as this object. But if you make a pendulum out of a bigger object that itself has a substantial mass that might even be equal to this mass, you have to understand that that's the mass you're moving in the gravity also. That this object is what you're moving in the gravity. You're lifting it in the gravity, a percentage of it. And, well, actually all of it. It's just that some of it you're not lifting as high as other parts of it. So you have to figure out where its center of gravity is, and you have to figure out how high you've lifted its center of gravity, center of mass. But the point is that center of mass might equal the mass you actually are comparing. So you can't compare a 1 mass, okay, to a 2 mass in an experiment, even with a lever or any kind of object, and have a big heavy object connecting them. If you have a heavy object connecting them, then that has to be included. And so you're really not making a comparison between a 1 mass and a 2 mass, because if you add this object, right, then you're stuck with the idea that this could weigh as much as the 1 mass. So this is a 1 mass and this is a 3 mass. So you're comparing two very different things when you're using another object. So you'd lose your 2-to-1 relationship. So to get back to your 2-to-1 relationship, you have to change the masses appropriately to compensate for the weight of the actual pendulum. So obviously the experiment he did was severely cheating, okay, because the one object is going to weigh a lot more than the other object, and you're not going to get a fair comparison between a change in its mass. Yeah, that should be simple enough, I believe. Alright, so now moving on to a email from the Leska character. I think there were two severe problems in your response to my thermodynamic lift and 5-ton train arguments. So there really weren't. So the thermodynamic one, he's arguing that somehow he can defeat the fact that gravity is a time-dependent force. That somehow you can undo this fact. Or that anybody even thinking about anti-gravity, I would argue, what you have to overcome is the example of if the sun had disappeared, there'd still be a whole bunch of force moving through the field, and everything would appear the same for 8 minutes, because the force takes time to get from point A to point B. And the problem is, if you want to do something anti-gravity, well, the only way you can undo the gravity that the Earth is creating is to put another Earth closer to you, and then that can undo the gravity that the first Earth is creating. Or speed. If you can move as fast as the force is moving, say the speed of light, then you can sort of undo the force by just evading it entirely. but you'd have to go like a warp speed. You'd have to really undo it. But the problem is it's still there. Okay, the force is a physical object that you actually have to plow through. And the fact that it keeps moving, okay, through a field doesn't change the fact that you still have to get through the minimum amount. All right, and if you're doing it at a higher speed, that means you're going to impact on that force more because of how fast you're going. Now, at small speeds, you can take advantage, but at high speed, it's the same thing as just moving the force at the speed of light into you. You moving into a force going, like say rain. Say rain was falling between me and the camera. If I move the speed of light through the rain, I still have to hit the raindrops that are in the way. And I'm going to hit them at a very high speed. If I'm going as fast as the rain is falling, I'm going to end up hitting them with a high speed, which means a higher momentum. And the collisions are going to be more significant because of the higher speed I'm moving into hitting the force. And it just depends on how fast I'm going versus how substantial the raindrops are now. So that's the argument. Now, in the case of gravity, the gravity force is very weak in terms of its density. And so if you go fast through a field of that rain, the faster you're going means you're hitting a force. You're not hitting material objects. So unlike raindrops, it's not material objects. But anyway, you can't undo the time dependence. The time dependence is the thing that you have to explain away, and that's the part you can't evade. So finding some other way to push something up isn't going to help you. It's already a proven fact. Okay, you go twice the speed, all right, you go 4 times the height. That's the, damn thing didn't. Always something. This was working a moment ago, okay? So if I go twice the velocity, I'll go 4 times the height. That's the fact, okay? So this is the fact you're trying to undo or find a catch around. Is the fact that this is all you get for one velocity, and this is what you get for doubling your velocity, okay? So that's the fact you're trying to undo, and that's the time dependence. So sitting there and saying that you can make a thermodynamic lift, well, the thermodynamic lift is the same idea. If I'm letting things in that have heat, if I let 500 things in, okay, that have that are, let's say, 100 degrees each. So I let 500 things that are 100 degrees each in, or I can let 250 in, okay, that are 200 degrees, or I can do some other combination. I can take half of that, 125 at 100 degrees. No, that's the wrong way. 400 degrees. So it's just a matter of how much you're putting in. The heat is a real substance. It has real momentum. So you're stuck with the same argument that it's about the momentum. And in this case, the idea is to get the most in fast. So you want, if you could do 1,000 degrees, that's what you'd want to do because it takes the less time for it to have an effect and push. So again, it's just a timed equation. You can't change that. You can't find some cheaper way to get it here except this velocity. And if you go faster, okay, you go three times the velocity. That problem is that, well, yes, you got to this height quick, but you got too far. You put too much energy in, so you still pay too much. There's only one speed that is the perfect speed to get to this particular spot the most efficiently. That's what I said in the video, and it's 100% the truth and accurate. And so your rhetoric is just rhetoric. You're just saying so. You're not demonstrating so. You're not going to link to any evidence demonstrating that what you're saying is true. Okay, so I'll read what he said. Problem 1. You still didn't touch on the thermodynamic lift argument. Well, I did in the previous video, the first time I responded to your video. Can you give a mechanical explanation on what's happening to the extra energy in a slower lift? There's no such thing as the extra energy beyond the fact that, again, it's just about how fast you lift it, period. And to lift it faster, you're going to have to put more energy in. You can't You can't lift it faster. You can't produce the 1,000 degrees without putting in extra fuel to get to 1,000 degrees. All right. Where is the energy going to? So there's nothing that has to go anywhere. Again, you can't make free momentum. The momentum costs you the same amount per unit. So you're just stuck with the problem that if you want to lift it more efficiently, you have to lift it faster. Okay, to keep things simple, note we are not talking about launching an object but steadily lifting it. And that's part of the problem also. But it doesn't really matter because gravity is a constant force. So you can't evade the constancy. And you certainly, by taking more time, can't evade the constancy because you're totally destroying the efficiency of going faster. Anything slower is less efficient. It can't possibly be more efficient because you're giving away your velocity by stopping. Anything that stops your motion means you have to restart your velocity, and your restarting your velocity has the same 1, 3, 5 rules. Gaining extra velocity takes time, and that's time you can't afford to give away. All right, to keep things simple, note that we are not talking, yes we are, because it's a constant force. All right. Problem 2. This was a big one. You said when you are compressing a spring, the 0-volt train won't start moving. Yes, and it's an absolute fact. It can't move if the spring is moving. If the spring is compressing, it means the force isn't going to the object. Now, I'm not saying no force goes to the object. I'm just saying the substance of the force isn't going to the object. So if there's a spring in front of me here, somebody throws a bowling ball, I obviously will not feel the full impact of the bowling ball. Part of the bowling ball's energy will compress the spring, and I will be spared a percentage of that momentum. And then the spring will throw the ball back, which means all of its momentum won't get to me. All right. But this is, he said clearly in bold, a false claim. So it is not. You'll have no evidence that it's a false claim. It's completely correct. Springs absorb momentum. They absorb energy in the form of momentum. You cannot possibly compress a spring without taking something's momentum. No other way to do it. Hold one end of a spring with your right hand and compress the spring by pushing on the other end with your left hand. So again, how is this this is your experiment that's going to prove something? Okay, you feel the same push on your right hand. Yeah, what you feel much slower than the actual dynamics. So there's no point in talking about what you feel. Okay, after you've compressed the spring and now you're holding its tension from both sides. Of course you feel the same. We're not talking about that. We're talking about the impulse that compressed the spring. And when you're compressing the spring, you're not going to feel any difference. Okay, don't you? That's the force making the OV train move. So again, it's just a lie. Okay, go ahead and show me a single experiment in the history of mankind where you compressed a spring and you didn't use any momentum. So you make a spring smaller, but you didn't use anything's momentum to do that. So show where that's the truth in any experiment ever in the history of science. This shows that momentum is perfectly transferred while the spring is compressed. Yes, after it's compressed. But before it's compressed, okay, it's going to consume the momentum. It's going to consume a percentage of the force. That percentage will not get to the person. Again, the bowling ball example. Somebody throws the bowling ball. If the spring compresses and throws the ball back, I'm not going to absorb the full impact of the bowling ball. All right, no momentum is lost, only kinetic energy. So more nonsense. You can't compress a spring without using momentum. You can't knock over a bowling pin without using momentum. You can't do anything that moves some other physical object must consume something's momentum. So you're full of shit and wrong. I really don't want to engage with you in these stupid, insipid arguments for which you have just claims and no fucking evidence at all. So, if you're not going to provide evidence of your claim that springs can be compressed without using anything's momentum, then fuck you. Okay, so it's just a waste of my time. All right, so just those additions. Yeah, so the whole idea of, like I said, I should have noticed that he changed the pendulum from a string to a frickin' stick. Big difference. Huge mistake in the reasoning. You're no longer comparing a 1 mass to a 2 mass. You're comparing whatever, a 1.5 mass to a 2.5 mass. It's no longer a 2 to 1 relationship. I suppose we should see if anybody commented on that change that I didn't notice right away, just for the sake of completeness. Let's see, where is it? Is that it? No, that's not it. All right, there we are. Let's just see if there's any comments on the video. Turn that on, and we definitely don't need it that big anymore. Why doesn't this thing do, it should select the right goddamn object. Just little flaws in these programs are annoying. Alright. So let's click on it and see what the comments are. Oh, I can't click on it there. I have to click on it here. Huh.
Okay, guys.
Okay, guys. So he's got it on a stick. A big, giant pile of stick with lots of crap on it. Completely different experiment. So I should have noticed that. 26 comments. Hilarious. That's a lot of comments, right? What the hell are they talking about? P.S. You're a poet and you don't know it. Well, that's Brozo. That was brilliant. Let's see. I knew he was going to say the magnets are time-dependent force. Yes, because it's true. Okay. If he just realized that springs are basically the same. How are springs the same? Springs obey Hooke's law. Magnets do not. Magnets get stronger and stronger and stronger the closer they get to each other. So per unit of distance, their magnitude increases dramatically. Then it would be so close to understanding why the velocity is squared in KE. So I don't know. That's just a nonsense argument. So fuck you again. Okay, not much to say. Explain further with your spring analogy, please. Yes, exactly how are springs analogous? And the combining two masses. See, Ian Gosling does believe that springs get harder to push. He doesn't believe in Hooke's law. Okay, he thinks they store more and more energy the more you compress them, it's quadratic. Compress them twice as much, it's 4 times as much energy. So he doesn't really believe in Hooke's law. Losing half the KE. Is there a Walter Lewin example Gary is basing this on, which I can watch? What am I basing what on? This time-dependent argument is an argument forever. I just don't know. You can believe distance is fun to play with. I'm just saying you have to concede that something that's moving a speed is a time-dependent thing. You can't really separate it. If it's moving a speed, it's time-dependent. And they're all moving the speed of light. So, yeah, there's no Professor Lewin video that's going to explain that to you, I guess. Did he use a spring to combine the two masses? I don't even know what that means. No, of course not. Because it won't work. You'd have to lock the spring. The spring would have to go get compressed. Then he has to lock the spring so it doesn't push the other object back, because obviously that would not mean they combined. So you're combining two objects, and if you use a spring between them, then compressing the spring, you can just logically understand if I'm compressing the spring and pushing the object, I can't do both. I can't I can't put energy into the spring and put all the energy into the cart. I can't do both things. That's not that hard to understand. You really need a Professor Lewin video to explain to you that you can't put the energy into both glasses. I can't pour the energy into the spring and then pour all the energy into the cart. The cart has the vertical momentum. the linear momentum, the spring has stored energy. I can't put the energy into the battery, into the storage, and then also put the energy into the moving object. I can't do both things. I can't recharge the battery of my car because of the way it's rolling. You know what I'm saying? I can't have it do both things. I can't make the energy run the car and recharge the battery. Okay. Let's see. Thanks for the video. And this is Walker. He's always nutty. I don't know if it's worth reading all this. But I predict that Goofy will argue that you have taken the mass of the rod into account. There he goes. So he got it right. And wouldn't that be rational for me to argue that he hasn't taken the mass of the rod into account? Of course, he's completely changed the experiment because it's no longer a 1 mass against a 2 mass. It's now a 1.5 mass against a 2.5 mass. The ratio of the masses is completely broken. Okay, in which case the ratio of the 2 masses will no longer be 2 to 1, you see. So at least he predicted what I would do correctly. The ratio of the height of the center of mass will still roughly be 2 to 1, I guess. Why would it be 2 to 1? The center of masses won't even be in the same place. Well, anyway, there's probably no point in reading the rest of that. Have a good one. Okay, so let's see what he says. Let's see what's... Okay, Brozo responds. Hi, John. Hope you're well. I forgot about the rod. Oh, there they go. See, I didn't see it, frankly. I just didn't even notice it. Would it be feasible to find the center of mass in each case by finding the balancing point? And the center of mass is just going to tell you that one's heavier than the other, but it's never going to be 2 to 1 again. Okay, you can't possibly turn it into a 2-in-1 comparison, because the extra mass is diluting it. There's no way to undo the dilution. Say on a pencil. Sounds fiddly and crude, so I imagine there's a better way. Yeah, the better way is to measure the mass of the rod and calculate its center of mass. I don't see what chance you have of... Then you have to do the arc and all the rest of it. I mean, because the total mass, yes, is variable in terms of how much work it's doing against gravity. So you are really complicating things by using a rod, because it's really hard to calculate the extra weight you actually added. Hopefully it's such a small difference. So who could think it's a small difference? It's a big, heavy piece of wood. How could you possibly think it's a small difference? It's a gigantic difference. If you just swung the wood, it would swing, you know, maybe for a couple of minutes because of how much energy there is there. That's it's pointless iron going an extra mile for someone who isn't listening anyway. Listening to what? Nonsense. Nonsense theory. Theory where you say a force that moves a specific speed isn't a time-dependent energy producer, when anything moving a speed produces energy in a time-dependent way. Okay. Let's see. So that's just too pathetic. That's all he's got now is excuses. So that's all he says about something so dramatically obvious, that you've changed the weights that are being compared. And it's a fundamental change in the experiment. 2 to 1 is different than 1.5 to 2.5. Okay. Would not make it nearer the 2 than 1.4 if I changed anything. Worst case, 1.5. So that's the joke. You already got 1.5. His answer was 1.48. So he was already close to 1.5, frankly. And he doesn't think the stick makes a difference. So he puts a gigantic stick as part of the mass moving. So this is back to the lever argument. He doesn't understand that when you do a lever experiment, you're putting energy into the system and you want to transfer the energy from this side to this side, that the motion of the lever has to be included because it's real momentum. The lever's really moving, and it doesn't magically stop moving and give its energy to the object that already left. You know, when it's moving, it doesn't stop and the object goes. You know, the lever keeps moving. It's still got the momentum. It's consuming a percentage of the energy. And he can't understand that. Alright, so Walker says to Stephen, I better ask you how you are doing, my friend. Okay, well, fuck this. Do you know about where the pain comes from yet? maybe you need an operation. So he must talk about all this crap somewhere else. Let's see. You had me going with the two pencil remark, LOL. I don't know what that is. Nice one. I'm more or less free of pain lately. Okay, who cares? All right, good to hear, brother. All right, so never. Whatever. Okay. Yeah, back pain is a bitch. I mean, I've had it since I was, 17, so I know what it is. Why did you replace the string with a rod? So Leska also figured that out. Or he read the comments, who knows which way it happened. I mean, it's to keep the weight at a desired angle, the rod makes it a bit complicated because the mass ratio is not exactly 2 to 1. It's not anywhere close to 2 to 1. And the centers of mass are at different positions. Well, like I said, the center of mass doesn't really matter because it's forced to hit at the same location. It's going to have the same momentum, but the total momentum is obviously different because the mass of the stick is going to be part of the impact momentum. All right. So just really poor. So, and then Brozo says, excellent invention, iron. So obviously it's not very excellent. First off, where was it ever proven that magnets release, independent of speed? That is, they apply the same force no matter how fast you hit them. So that's like proving, in my opinion, that wood breaks exactly the same no matter how you apply the pressure. When we already know that, no, it fractures and breaks with a lot less energy if you can apply the energy quickly. I'm just wondering if the results would be even closer to 1.4 if measured to the center of mass. So again, what good would center of mass do you? Because the two of them have a different center of mass. The two objects can't have the same center of mass. You'd have to put them at different locations, and then you'd have to hit the lever at different points. Even so, you've proved your point already. So where did he prove anything except that he cheats and lies about experiments? Obviously, this doesn't demonstrate his kinetic energy theory. Because DS would expect them to have the same momentum to do the same work. No, I wouldn't. I expected it to be twice as the height, 4 times the height. So another half distance away, he still would have to go for them to have the same energy. Retard. And clearly you didn't need to double the velocity of the half mass. So I don't know, 8 hours ago, when was this other comment where he's conceding that the measurement is wrong? I mean, too ridiculous. All right, DS would expect that. Okay, double. All right, nice debunking of DS yet again. So it has 2 flaws in it. First, he adds a stick that ruins the 2 to 1 relationship, and he's not accounting for the fact that magnets, like all the other forces moving the speed of light, is time dependent. All right, just seeing John's point regarding rod mass needed to be taken into account. I wonder if we can do that by simply finding the balancing point of the rod assemblies. Again, it won't do you any good. It won't change the fact that it's no longer a 2 to 1 relationship. You have to change the weights on the stick to recover the 2 to 1 relationship. All right, thanks, Steve. Not bothered by excuses. Little changes wouldn't alter the one force to a major degree. So he's just saying the same thing. He has no reason to believe it wouldn't make a difference. He's just saying it doesn't make a difference because he's just going to keep defending being a liar. So he's made another fake, phony video implying a result that isn't the actual truth. He's just deceiving people again, and he doesn't really care. Deception is fun. Okay, that's their motto. And it goes all the way back to the silly clay experiments of the 1700s. They were just deceptive. The physics is clear. Dropping round objects, denting clay with a round surface is not a linear measurement of energy. Okay. So, and then Brozo just says, I agree. So he agrees it doesn't matter how heavy the stick is. It doesn't matter. Go ahead, make it out of steel. Too silly. DS would still make excuses even if you got NASA to do it. So again, he's bringing up NASA, where again, you're not going to show any NASA experiments, right? They don't do any experiments in space proving kinetic energy, because guess what? It doesn't happen in space. So they do these simple little nonsense experiments, and they don't get to any of the 10-ton train, 5-ton train experiments, because guess what? If they did those experiments, the truth would be revealed quite obviously. See, it's so easy for them just to take two tennis balls, two objects, and they could move one at half the speed and have twice the weight, and one have a full mass, and they could just push them away from each other, one at twice the velocity and one at one velocity, and they could just watch the string, and they could watch the whole thing happen, and they just bounce back and forth because it's all the same amount of energy. All right. You simply need to weigh the rod, Steve. The balancing point is indeed where the center of mass lives. Again, weighing the rod will not help because you've lost the 2-to-1 relationship. So you have to take away weight from one of the objects. In this case, you have to take weight off of the light object. Okay, I believe. Do you have evidence that the velocity is going 1.4? Just doing the math saying it's 1.4 is going to cut it for me. Okay, so this is base and mass. Well, we already know how gravity works, so we're just saying based on height, you can tell how fast it's going. That's all we need. So at 0.5, the height, if you lift something 2 units of height, twice the height, it will give you 0.4, the velocity. Okay. If I lift it 4 units of height, it'll give me twice the velocity. Also, the magnet is suspect and could add a variable to the experiment. Well, the variable it adds is quite obviously the fact that it's just another time-dependent force. And there's no evidence that it equally applies counter pressure to independent of how fast you apply your pressure. So the fact is, the faster you can pull the magnet apart, the less work you will do. Elaborate on why you think the magnet is suspect. Okay. Well, it doesn't seem necessary to have them to begin with. It's also adding a force that the masses need to overcome in order to knock down the wood. Yes, and it's not adding a force that's not, again, a time-dependent force. The force of magnetism moves at the speed of light. It is a time-dependent force. I just keep saying that over and over. With the wood alone, vertically, it would take no force to topple it. Exactly. Overcoming the magnetic attraction seems a good way to offer the same force to both masses to overcome. But the trick is, it's not the same force. Now, if you put it on a lever and you hit the fast and you made the lever move at the same speed, then the magnet will work. So if you have your lever and you put your fulcrum here instead of at the bottom, right? And you pull the magnets apart this way, all right, the same speed, and then you hit the lever, at the 2 distance point versus the 1 distant point, and then compensate for the weight of the lever. Yeah, but you have to pull on the magnet at the same velocity. If you're pulling on the magnet with different velocities, you'll get different outcomes because it's a time-dependent force. Okay, it's not disputed that 4x the height would give 2x the velocity. 2.2 times is a big difference. And again, it's for 2 reasons. All right, let's see. A brake test would be more straightforward a setup used in the last video. So again, braking now depends on the size of the disc or whatever you're using to apply the friction. So as the other liar demonstrated, Falwell demonstrated in his video, it makes a difference if you put the same friction point, the same pivot, and you double the weight, you'll change how much friction. If I have let's say I have 2 hacksaw blades, and I swing one on a pivot, and then I double it, I put a second one, but I allow it to have its own fulcrum, all right? Then they'll swing at the same rate. But if I tie the two blades together and only use one of the holes in the blade, so now all the weight is on one friction point, it'll completely change how fast, how long it keeps swinging, because you're reducing the amount of friction, because you're lost the whole surface you're creating friction on. All right, increase the speed, can't diminish the force required. So again, they don't understand that magnets are like all other things that are controlled by a speed of light force, completely controlled by time. Okay, in case that's what you're thinking. Otherwise, we could exploit such a non-existent property of magnets to acquire free energy. How could you exploit it? I mean, the fact that you can lift a weight slow and make it more work, you can't exploit that to make free energy. Sorry, you can't do that. Ugh, idiot. I mean, what an idiot. Okay. The only case I can think of where speed would affect the force required to release would work the exact opposite way. And that is if for some odd reason he used this is such nonsense, strong magnet coupled with, say, copper, so that the magnet breaking effect of Lenz's law would hinder the wood falling. So again, Lenz's law is in a sense illustrating the very point that it's time dependent. Lenz's law is about velocity. The faster you move something into the copper, the faster you move a magnet into the copper, the more counterforce it produces. The slower you move it into the copper, the less force it produces. In that case, the faster the action, the greater the force required. Exactly. Okay. He didn't do that, of course, so the magnet offers some resistance, requires some force, some energy to release in both cases. It's just like releasing something from Earth's gravity. It's no different. The magnetic force gets, like gravity, it gets stronger the closer you are to the surface. Now, it's not an inverse square law, it's a cubed law, probably, but they've never really tested it. But regardless, the fact is it does change. The closer you are to the surface, the more force required, blah, 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 blah. And the fact is, the faster you go through that transition, the less force you're going to have to fight. All right. Do you want to acknowledge that almost all basic collision experiments, one mass going to a stationary two mass elastically, debunk your notion of momentum as incorrect? So again, there are no experiments that are done in any kind of clinical fashion, I would argue. So you don't have any of those experiments. And the simple experiment, as I've illustrated, I say it over and over again, you can take the pendulums and you can prove the point. Okay, you can't take 100 momentums going this way and 200 momentums going this way and have 100 momentums pop out. That can't happen. All right, so you can keep pretending you have some evidence, but you don't. And the simple experiment is, yes, 5 mass, 10 velocity going this way, 10 mass, 5 velocity going this way, and just tie a string between them, and the 5 mass isn't going to win. It's not going to pull the 10 mass in its direction. It's not going to happen, ever. And all of the collision experiments between real cars, like in the Mythbuster example, proves this case, that twice the speed, twice the compression. Not 4 times, twice. So just a lie. All right. Let's see. It's been months, so he placed another comment. I don't know why these assholes who can't figure out how to do their comments in one comment, or how to edit a comment and add something to it. It's been months, and yet you still want to pretend, so he doesn't even have it addressed to the guy he's talking to. Pretend like you want to have some kind of good faith conversation when everything tells us it's the opposite. So you have 2 factors you have no evidence for. First, that the magnets are not time dependent. That is, you can't make it easier to pull them apart by moving them faster. And 2, that the big giant stick didn't completely fuck the experiment. So you haven't demonstrated that you've accepted either one of those conditions on this experiment being complete nonsense. All right, you said you don't like it when people move from one experiment to another, so let's see if you can deal with just one that is already proposed and showed. How long will you keep evading? I don't know what he's saying here. If he's defending this experiment, he's obviously defending nonsense. Okay, if you believe the ratio of the velocities being the square root of 2 in all these experiments, you can ask Stephen Bro politely if he can count to the frames with his video editing software to convince you. So why would anyone bother with frames on this video? Otherwise, you remain with the burden to prove all physics books being wrong. So I don't even know who he's talking to. So physics books do not say anything about this nonsense, frankly, this 1.4 rule. Physics books say you have to conserve momentum. Frankly, that's what physics books say. And even Professor Lewin, again, I can quote him over and over and over again. MIT professor said, nature can deal with kinetic energy one way or another, like in the case of the bullet where 99% of the kinetic energy just disappears. But nature can't finagle momentum. Okay, that's what the physics books say, liar. All right, what's the symbol between the square root and the h, please, John? I don't know. Why would you even interact with this this free energy nut? Okay, so let's see if there's anything else. Proportional is similar to equals then. Well, usually proportional does mean an equality, but frankly the problem is proportional can also mean that this is going 10 miles an hour and this is going 50 miles an hour. You double this to 100 and you double this to 20. So it's a proportional change in something. So sometimes you can use the word proportional and you're saying, yes, there's a direct equality, really. And then other times you're saying, no, the change is proportional. It's not explicitly the same, but they both change the same amount. All right. So, yeah, no point in worrying about his notation because he's an idiot. He thinks hot chili peppers create magnetic effects that create perpetual motion. Yeah, he's that nutty. So anyway, so yes, big stick, bad idea. That's the essence of the video. But obviously the rest of the context is good to bring up. So no harm in that. So till the next time and such, just consider this a add-on of some kind.